Hey guys, so we have logarithms this week, right? So we're going to start with some properties, some pretty basic properties for today. And then the next one is going to be just a little bit tougher properties. So it's really just about learning these rules, guys, and being able to apply them. So the rules is really the bread and butter of these assignments. If you can understand the rules, you're going to pass this stuff with flying colors, right? And if you're having a little bit of trouble, you just got to practice a little bit more. And once that application process becomes a little more clear, it'll become a walk in the park, right? So we've just got to kind of dive into these rules, and hopefully we can understand them best we can, and then we'll apply them here in a sec, right? So let's start with this first rule. So basically this says log base A, right? So that's base A of C, let me rewrite that, C equals B. Right, so I've got a blue, a red, and a green, right? A, B, and C. So I can rewrite this. Now, this is going to look like an exponential kind of thing, which is exactly right. Exponentials and logarithms are inverses of each other. So they're going to have some similar properties, some inverse properties, all that kind of stuff. So basically, we can write this logarithmic problem as an exponential expression, right? So what we're going to do here is take that base A, and we can raise it to the B, and that's going to equal the C over there. Right, so we can take whatever that base is. So A, raise it to the other side of the equal sign, B, and that should be equal to C, what we have on the other side. Right? And yes, that sounds like gibberish. That sounds like, what the heck just happened? I've never seen this before in my life. Don't worry about it, right? We're going to start to understand that here in a second. Just make sure that you see the colors, you see how we're rearranging it, and we're going to apply those here in a second, okay? So then we can kind of move over here, and it makes the same sense going backwards, right? If I have, let me get these same colors. If I have an A already, and I have a B over here, and I have a C, if I have this kind of exponential expression here, I can rewrite that as a logarithmic expression. So I can say, okay, if that's the case, then I can take log base A of C, and that's going to equal B. Okay, so that's our main two rules. Now, it's really the same rule, just backwards and forwards. Okay, but if we can kind of memorize that, if we can understand that, then we're going to be just fine for the majority of this. And then we're going to come back to this inverse rule of logarithms, logarithms, that's silly, but we'll come back to this inverse rule of logarithms, okay? But for now, let's just kind of skip on and apply this first property that we've kind of grown accustomed to. So first things first, let's just write it rearranged. Let's just rearrange it best we can, okay? So I'm going to continue to color code this, and hopefully it works, color code this. And hopefully this works, okay? Hopefully you start to see the colors, you start to see what's happening, and it'll all be okay. Okay, so first things first, like I said, let's just rearrange. So we have log base 6 of 36 equals 2, right? So my problem up here tells me I can take the base and raise it to the other side of the equal sign. So really what I'm doing is I'm taking this, let's zoom in here, I'm taking this and raising it to that. And then it's going to equal the C, right? Taking the base, raising it to the other side. So let's try that. So if we do the same thing here, I'm going to take this base, raise it to the other side. So 6 raised to the 2. So let's do that, right? So let's get our little implies here. And then let's take this 6, and that's going to be raised to the second power. And that should equal 36. Now, hopefully everyone knows what 6 squared is, right? It's 36. So this holds true. Yay. Right? That holds true. 6 squared is in fact 36. So this should kind of sell you a little bit. Now, don't just take my word for it, right? We'll continue to see that this is going to make sense. But hopefully you see that this does, in fact, if we rearrange it the way we're supposed to, it should give us a true statement, right? 6 squared does equal 36. We all know that. Right, so that's exactly what we're doing here. Okay, so let's move on to the second one. Right, so this time it gets a little bit more complicated. So we have log base 2 of 1/4 equals -2. Okay? Again, we just raise the base to the other side of the equal sign. So that's exactly what we're going to do. So this implies that this should be true over here. So we've got the base 2 raised to the -2 should equal 1/4. Now, does it? Well, let's do a little bit of algebra here, right? So we have 2 to the -2. Remember that negative up here just means, actually I'm not going to write on there. That negative up there just means I'm going to flip it and get rid of the negative. So really I have 1 over 2 squared. And we know 2 squared is 4, so that should equal 1/4, and that's exactly what happens. So yay, we have a correct statement, we have a true statement. It's all good, right? So hopefully you're starting to see this kind of pattern. Is it hard? Not at all, right? Not at all. It's just a matter of knowing this rule. Once you know the rule, this becomes very clear. Now, for some of you, this still might be unclear, and that's fine. You just got to continue to practice and continue to hopefully find that pattern, right? So number 3, now we're going to go backwards, right? So now we're going to go like this. So we're going to start with the exponential expression and work our way to making it a logarithmic function. Or expression, I'm sorry. Expression, not a function, okay? So let's do it with the same color coding, right? So I've got 3 to the 3rd equals 27. Now that's a true statement. We know that. 3 to the 3rd, 3 times 3 times 3 is 27. Okay, but let's kind of rewrite this as a log function. Let's go the opposite way. So I've got log base 3. Remember the 27 goes here. And that should equal whatever the exponent is on the left, which is 3. And there you go. Oh, that's horrible. Right, there you go. Okay, so now we're just going backwards. No big deal. If you want, go ahead and put this in your calculator and see if it gives you a true statement. Put log base 3 of 27 and see if it equals 3. It very well should, because we know that to be true, right? But this stuff isn't really exactly things we can do in our head to check, so you just kind of have to trust yourself a little bit, or like I said, you can go ahead and use the calculator to see if that holds true. Okay, so then coming down to number 4, same business, same deal, right? Same deal. So we have this base number here, we have the 0 up here, and we have the 1 over here. Now, we know that's true. 20 to the 0 power is 1. Anything to the 0 power is 1, right? Anything. 1,000,000 to the 0 power is 1, so on and so forth. So let's rewrite this as a logarithmic expression, sorry. So we have log base 20 of 1 equals 0. That's a 0, right? And that holds true. Again, go ahead and check in your calculator, right, if you don't believe me. Okay, go ahead and put in log base 20 of 1, see if that equals 0. It's going to equal 0. Okay? Okay, so hopefully that makes sense. Hopefully you see that pattern. Remember, if it helps, color code it, right? Go ahead and write these rules right up here, color code them, and then go ahead and apply that rule. It's just like I did, right? Colors help. Color coding helps. All right, so let's come down here and start evaluating. Let's kind of use our knowledge now to find a missing number. Now it gets a little bit complicated. There's going to be some that are pretty simple, some that are not so simple. And first things first, when I look at this one does not to be so simple. Looks like I had a typo. So let's go ahead and cross that out really quick. And let's rewrite that. It's supposed to be log base 7 of 49. That's going to make it a lot easier on us. Okay, so go ahead and write that down, and then let's get started. So first things first, what you want to do is kind of color code it, right? So let's go ahead and do that. So we have our base. It's going to be the same deal, guys, and then we have of 49, which is red, and then we have it equaling a green number that we do not know what it is. What do we usually put for a number we don't know? X, right? The tried and true X. So let's go ahead and just rewrite this. Let's just rewrite it first. So let's bring it down here, and let's make this an exponential expression. So, of course, we have the base here, 7. And remember, that base is being raised to over here, so it's 7 to the x power, and that's going to equal our 49 that's over here. Now this becomes a thing of just asking yourself, 7 to the what power gives me 49? So 7 raised to what power gives me 49? This one's pretty simple. Hopefully we know that 7 squared is 49, right? So we know 7 squared is 49. Therefore, x equals 2. Right, so that missing number that we need is 2. Because if we were to fill in that blank, that's what we would need to put in there. Okay? Unfortunately, there is a way to solve that, which is a little bit algebraic, but it involves changing the base of things, and that can get a little bit complicated. So we're just going to kind of talking about filling in the blanks here, right? 7 to the what power gives me 49. That's what you're going to have to do, right? It's going to be a little bit ugly, and a little bit time consuming, but really guessing and checking could work, right? You say 7 to the what equals 49, you can just put 7 times 7. If that doesn't work, try 7 times 7 times 7. If that doesn't work, so on and so forth, right? So let's move on to this one, number 6, right? So again, we have a base, we have a number here, but what we do not have is a number here, x. That's what we're looking for, right? So again, let's rewrite this as an exponential expression. So we're going to take the 8, and again, we always raise that to the other side. So 8 to the x equals 1 over 512. And again, you might be looking at this, and let me kind of separate this out with a different color. So again, you might be looking at this saying, oh my goodness, that looks ridiculously hard. I'm never going to get that, and I'm just going to quit now. Or you can be putting this into like something like insolve, something like that. But remember, guys, this is just as simple as guessing and checking, right? It really is. So we're saying 8 raised to the what? 8 raised to the what power gives me 1 over 512. Well, that fraction that we're getting is coming from what? Hopefully you guys are clever enough to understand what this means, right? We've talked about it plenty of times. This means that x is going to be what? Positive or negative? Well, it's going to be negative because a negative exponent gives me the reciprocal, a fraction, right? So we know x is going to be negative. So all we have to find out is 8 to the what gives me 512, right? So again, that's as simple as guessing and checking. 8 times 8 is what? 64. Okay, 64 times 8 is what? 512. There you go. So how many 8s was that? It was, let's write them down. 8 times 8 was 64 times another 8 was 512. So that's 1, 2, 3. So 8 to the third. But again, you need it to be negative because it's a fraction over here. So x is going to be -3. And there you go. Okay, now listen, guys. If before I go on, if what's tripping you up is the math part, the algebra part, the saying 8 to the what power is 1 over 512, and then you get stuck, that's okay. That's a good spot to get stuck, right? That's fixable. What I want to worry about is understanding going from here to here, right? If you can't really solve it, that's what calculators are for. You're going to be able to do that in a calculator. No big deal. You can insolve it. But if you can't get to here, then there's an issue, right? You've got to be able to rewrite this log expression to look like this, and then the rest comes later. We can worry about all that later, right? So make sure you're understanding these properties, okay? So let's move on to simplifying this, and that's actually going to be really simple once we learn the inverse rule of logarithms, right? It's logarithms. But we just got to learn this really quick, so let's go ahead and learn it. So basically what this is saying, remember what I said earlier, logarithmic functions and exponential functions are inverses of each other. Now, what do you think of when you think of inverses? Well, multiplication and division. What do those do? They cancel each other out, right? If I take 4 and I multiply by 2 and then I divide by 2, right? That's going to be 8, and then 8 divided by 2 is 4. So really, all I'm ending up with is that beginning number. Why? Because these cancel each other out. They're inverses, right? They cancel each other out. So when you think of that kind of stuff, inverses canceling each other out, then that should be exactly what happens here, and that is exactly what happens here. Okay, so let's look at it. So if I have base A, and it's raised to the log base A, right? As long as those two bases are the same, these will indeed cancel out, and all I'll be left with is the B in the top. But what's important is those two bases are the same, right? I have base A and then I have log base A. That's when they cancel out. As long as they're the same, they cancel out. And this is going to be a pretty easy one to see, because here, you see I have base A, or base 2, I'm sorry. I have base 2 and then I have log base 2. So do these cancel out? Of course they do. They're the same bases. So they'll cancel out. What am I left with? Just the 14, big old 14, and it's simple as that. Okay, it really is. It truly is as simple as that. So let's come down and let's apply that, right? So this is where this number 7 comes in handy, right? And this is going to kind of knock a couple of birds out with one stone. Remember, E is a number. I promise it is, right? So E is a number. It's kind of like pi a little bit. So E is a number, and then this ln is natural log. Now, natural log just means this is log base E. That's all that means. So, do these have the same base? Well, yeah, because natural log is log base E. What's the base over here? E. So, there you go. They'll cancel out. So, let's get out a cancel out color. These will cancel out. And all I'm left with here is a big whopping 13. So now coming down here, this is going to look a little bit different, okay? But again, it's the same kind of thing as before. So this is before the one we did. I kind of wrote these a little bit out of order. That's okay. All right, so let's kind of check to see if we remember the first properties we were talking about. So let's go ahead and do this. So we have base 6. We have the red one here. And then it's going to equal. Now we can't use x this time because now there's an x already there. So let's go ahead and use, I don't know, let's use y. No, I don't want to use y, actually. Let's take that back. Let's use, I don't know, a. A sounds fun. Let's use a. So again, we just got to rewrite this. Remember, this 6 is just raised to that over here. And usually I circle it, so let's circle it. So let's rewrite this. We have base 6 raised to the a, and that's going to equal this 6 to the 11x. Now, what happens here? What happens here, right? What is a going to be equal to? Well, 6 to the 11x can only be equal to what's over here if a equals what? Well, a's got to equal that 11x. It's got to equal it. So let's go ahead and write that so that we know that a, not a marker, a equals 11x. That's the only way. Now, I wanted to show you that way because you can do this one of two ways, right? You can do this one of two ways. Let's go ahead and rewrite this really quick over here. So we've got log base 6 of 6 to the 11x. This can also cancel each other out because this over here are exponents, right? Because these are exponents here. Because we have base 6 and we have log base 6, right? And there's an exponent here. Then these can indeed cancel out. Bang, 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 right? And all that's left is 11x, which in both cases is the answer, right? Both cases is the answer. Okay, so hopefully these properties make sense to you. We're going to continue some different properties in the next video. Let us know if you have any questions, and hope you're having a great day.